We'll cover what LangGraph prompting is, why it matters, and then build it with code. This LangGraph node has start node, end node, LLM node and tool node. In between these nodes are connected by edges, which represent direct flow between these nodes. But there are conditional edges, which indicates flow will only possible when certain conditions are met. Let's start by exploring LangGraph workflow. Let's say user's query for basic arithmetic operation. Here in step 1, query to the LLM is 7 plus 4 multiplies by 3. Now this query reaches the LLM node, then it splits the tool call operation. Now here 7 plus 4 is sent as a tool call to perform addition operation. After performing addition on tool node, the result is 11, which is returned as tool message to LLM. In step 4, the response of previous output 11 and multiplies by 3. Now multiplication is sent as a tool call to perform multiplication operation. In step 5, the response 33 is returned as a tool message to pass it to LLM for further operation. Now the final output is 33, which we get as an output from the LLM. Now let's start building LangGraph workflow. Here we are loading environment variables. We need ChatGPT OpenAPI key, so we need to load those keys. Next we need to import LangChain tools, and init chat models. Now we initialize the chat model with ChatGPT as a model, then set the temperature as 0. We need to define tools to perform arithmetic operation. Here we define addition, multiplication and division operations. Next we need to bind the model with these tools so that we can perform the required operations. Now we are initializing message state as type dict. Here we are storing our conversation messages as an array and LLM calls to get the total number of calls executed by LLM. Now you can see the LLM invoke function. This has initial system message, then the user message is appended on each conversation. We are executing the LLM model with tools, user message and system message. Here the system message I have given as task to perform the basic arithmetic operation. Then, we are incrementing the LLM calls for each invocation. This code performs tool node operation here if the message contains tool calls. Then those calls are executed and returned as tool message. You can see the final message is appended tool message, which contains the result of tools operation. This code is condition execution. We are taking last message from the conversation, and we are checking if the messages has tool calls. If it has tools calls, then it will go to tool node to perform the operation. Then if it does not has any tool calls, then it will end the conversation. Now initialize the message state on the state graph. We will add the node LLM and tool. Previously we have added node, now we need to connect the nodes, so we need to add edge between the nodes. Initially we are adding edge for start node and LLM. Now you can see we are adding conditional logic between the LLM to tool node and LLM to end node. Should continue is the function which performs the routing functionality based on the conditional logic present in the function. We are also adding direct edge between tool node and LLM node. Next we are compiling the agent and display the resultant output as graph. Now we need to send the human message to invoke the agent. Here I'm sending the arithmetic operation, and I'm printing my result as pretty print. Also I'm printing the total LLM calls to my model. Let's invoke the agent and wait for the result. Let's analyze the output. Here the user input arithmetic operation is sent as human message. After that we can see the tool calls with arguments 3 and 4. Then the response from the tools as tool message after performing addition operation is 7. Then again we are sending the result of previous output and 7. We are getting the result from tool and AI message as 49. Also, in the output we can see the total LLM calls, which is 3. Thanks for watching the video. Please like, subscribe and share the video if you have liked.